Hi everybody, good morning. We're going to talk about areas of trapezoids here. I'm going to show you how we can derive the formula for the area of a trapezoid. Check out this one. Label the lower base as b sub 2, the lower base as b sub 1, and the upper base is b sub 2. Let the distance between these parallel lines on this trapezoid be h. I guess that'll be this length right there. Show diagonal AC. I can do that right away. And when I show that diagonal AC, that gives me a couple of triangles. And it's clear to me that if I could add up the area of triangle ABC and triangle ADC, I'd have the area of that trapezoid, if I could just add up these two triangles. So let me think about that. I'll try to write small. The area of triangle ABC plus the area of triangle ADC ought to equal the area of that trapezoid ABCD. But now how can we talk about the area of triangle ABC? That'd be 1/2 times its base times its height. Let me call that 1/2 times, and the base is B1, B sub 1, and the height would be what we've labeled as H. Plus, now what about this triangle ADC? Let's let this be the base. And I bet you're thinking, I hope you're thinking, if that's the base, then the height would be this segment, wouldn't it? But aren't these two congruent? Isn't that height and this height the same? Because these parallel lines are everywhere equidistant. So when I set up the area for this second triangle with that base and this height, then it could work with the same height. So that would have to be 1/2 times b sub 2 times h. And if I can add those two things up, I'll have the area of that trapezoid. And as I notice, as I look here, there's a couple things that are common. There's a 1/2 in both of them and an h in both of them. I got to pull those off to the side. 1/2 times h times, now what would I have to multiply that by to get both of these again? And actually it would have to be 1/2 times h times b sub 1 plus 1/2 times h times b sub 2. So you could write the formula like that, but I've kind of adapted it as I think about this and think it's the area of the trapezoid is base 1 plus base 2 divided by 2. I think of it as the average of the bases times the height. That really does come directly from this, I hope you see. Then we're going to get the area of a few trapezoids just to see how that goes. We'll start off with an isosceles trapezoid. And standard procedure, every time you're ever working with a trapezoid in this geometry class, is you'll drop these altitudes at either endpoint of the upper base. Like this one and that one. That gives you a couple of triangles to work with and a rectangle. This full length across the bottom is 27, but I recognize because this is a rectangle that part would have been 15. I'm also thinking that these two triangles are going to be congruent, since it's an isosceles trapezoid, and the base angles are congruent. That makes these two smaller segments also congruent. I know that the bottom side is of length 27, but this middle part is 15. So if I subtract those, I'll get 12 for these two parts to share. This must have been 6, and that must have been 6. I wonder if you already know the altitude. I do. And I'm going to instantiate that with a little Pythagorean triple. 6 squared plus 8 squared is equal to 10 squared. So I hope you're clued with me that the height has to have been 8. Then it's easy to get the area of that trapezoid. Base 1, 15. Plus base 2, 27. Add up the bases, divide by 2, then multiply by the altitude. And our altitude was 8. This gives me, I think that's 42 divided by 2. Therefore there's 21 times the height of 8, and that's 168. Real quick check on those kinds of things. Let's just figure the areas of those parts. What would be the area of that triangle? And 1/2 times 6 times 8 would have been 24. Plus the area of that rectangle in the middle is 120. Just length times width, 15 times 8. plus the area of this triangle, which is the same as the first one. That would have been another 24. And that gives me 48 and 120, and there's 168. So a little check on that, and because I make mistakes and everybody else does too, it's a good idea to make that check. Let's look at this trapezoid, and this one's interesting. It's got a couple of 60-degree angles. Standard procedure right away. Let's drop those altitudes at either endpoint of the upper base, yielding a couple of 30, 60, 90 triangles to play with, huh? I hope you remember, if the hypotenuse is 8, then opposite what must be the 30-degree angle would be the short side 4, and the longer leg 4 times the square root of 3. Because this is also an isosceles trapezoid, these triangles will be congruent. Also 8 there and 4 here, and yeah, that's still 4 square roots of 3. And we got this rectangle in the middle with this length, therefore 10. So the lower base, yeah, we got that, huh? 4 and 4 and 10, they got to be 18. Find the length of the lower base and the altitude. I'm going to say lower base was 18, and the altitude was 4 root 3. And get the area of that trapezoid. Base 1, 10, plus base 2, 18, divided by 2, and we'll multiply that by the altitude, 4 root 3. And that gives me what looks like 28 divided by 2, that's 14, and 14 times 4 is 56. 14 times 4, 56 square roots of 3. That's what I think it ought to be. Let's do a little quick check on that, why not? What would be the area of that triangle? 1/2 times 4 root 3 would be 8 root 3. And the rectangle in the middle is 40 root 3. And this triangle would be the same as that. There's another 8 root 3. And I hope you see that these three things are going to add up to that same 56 square roots of 3. I do think the formula is quicker. I just want to instantiate it every time. Oh boy, look at this. We got a couple 45-degree angles here. One more for practice in isosceles trapezoid. Standard procedure. Get those altitudes at either endpoint of the upper base. See what kind of triangles we're going to play with. Those are altitudes. They're perpendicular. If that's a 45, yeah, buddy, we got a 45, 45, 90. How big would these sides have to be? I know they're going to be the same size, and it's truly 10 divided by the square root of 2. And I do hope that you know that 10 divided by the square root of 2 is equal to 5 square roots of 2. So that's my altitude, 5 root 2 there. But it's also the length of this side as well. And these triangles are congruent, so I'll put them there as well. And this length is 10. Get the length of the altitude, yeah, it is 5 root 2, isn't it? And the length of the lower base is 10 plus 10 root 2. Now I figure I can get the area of that trapezoid, huh? Base 1, 10. Plus base 2, 10 plus 10 root 2. Divided by 2 times that altitude of 5 root 2. A couple places to be careful here. But here I see things that I can divide by 2, so I'll do that division. I have 20 divided by 2, that'll give me just 10. Plus, and 10 root 2 divided by 2 will give me 5 root 2. That should ought to be in parentheses. I think that's what we got from all of this. I got to multiply that times 5 root 2. We'll multiply that 5 root 2 through those parentheses, giving me 50 root 2. Plus, and what about 5 root 2 times 5 root 2? That's a place that a couple of mistakes have been made. That would give me 25 square roots of 4. 25 times the square root of 4, 25 times 2 is just going to give me 50. So I say that that trapezoid ought to be 50 plus 50 root 2. Real quick check on the side. How big would be the area of that triangle? Well, 1/2 times 5 root 2 times 5 root 2. When you multiply those, you're going to get 25 times 2. And when you take out half of that, that's just going to be 25. So 25 for this triangle and 25 for that triangle. I figure that's that 50. And that rectangle in the middle, yeah, that's 50 square roots of 2, huh? So I think we got that well done. Now here's a more interesting circumstance, a non-isosceles trapezoid. This is going to be more fun to play with. AD is 8. DC is 12. BC is an interesting length, 4 square roots of 7. And measure of angle A is 60. Here's a pretty good looking question. Let's jump in here. Get the length of the altitude and the length of the lower base. We'll need those to get the area anyway. Drop those altitudes, homie. Let's see what comes. Got a 30, 60, 90 on the left. Short side would be half the hypotenuse. That'll be 4. And the longer leg is 4 times the square root of 3. This length being 10 at the top makes this part of the base have to have also been, 12 at the top is 12 at the bottom. And you think, well, all I know is this, and I don't know any angles over here. But actually, you do know some more than that, don't you? If this is 4 root 3, the distance between these parallel lines are everywhere equidistant. So if this is 4 root 3, then this would be 4 root 3. So now I know the altitude. But it's going to be important that we find that length x right there, too. So I can get the length of the lower base. So I'm going to hit that with the Pythagorean theorem. 4 square roots of 3 squared plus x squared equals 4 square roots of 7 squared. I think it's going to be 8 for an interesting reason, but we'll see how that goes. How would you square that 4 square roots of 3? That'll be 16 times 3, 48, plus x squared. And when I square this, it'll be 4 squared is going to give me 16, and the square root of 7 squared is just going to be 7. So it's 16 times 7. And 16 times 7 is 112, I think. 16 times 7, yeah, that's 112. Now let's subtract 48 from both sides. Alexa, what's 112 minus 48?
Sorry, I didn't catch that.
Alexa, what's 112 minus 48? I think it's going to be 64.
112 minus 48 is 64.
That's nice, 64. Take the square root of both sides, and x would have been 8. Some interesting things about the Pythagorean theorem I kind of know about. I won't go into it right now. But, so we got the length of the lower base, don't we? The lower base is 24. The altitude is 4 root 3. Let's get that area. Base 1, 12. Plus base 2, 16, 24. Add those up, divide by 2, and then multiply by the altitude. Base 1, 12. Base 2 is 24 divided by 2 times the altitude 4 root 3. So when I add up the bases, I got 36 divided by 2. That'll be 18 times 4 root 3. 18 times 4 is 72, I'm pretty sure. So 72 square roots of 3. Now, that's interesting. Let's do the parts, see if it adds up that way. They're really pretty quick to do. If you just went 1/2 times the base times the height, a half of 4 is going to be 2 times that. It's going to give me 8 root 3. And I'm going to get that rectangle in the middle, and 4 times 12 is 48 root 3. And this triangle on the right, 1/2 times its base times its height, a half 8 is going to be 4, and 4 times 4 is going to give me 16 square roots of 3. So if I add those up, 16 and 8, there's 24 square roots of 3 plus 48 square roots of 3. Yeah, I'm pretty sure that's 72 square roots of 3. So that worked out pretty cleanly. I got a little trapezoid workout for you to do as well. I think it's quicker and easier than this one.